Ground level ozone formation. Photochemical smog. So this is the second part of the ozone problem lecture. Photochemical smog is a noxious mixture of highly reactive and oxidizing air pollutants. It includes oxides of nitrogen. There may be nitrogen dioxide, nitrogen oxide, and it consists of volatile organic compounds, hydrocarbon, aldehyde, ketone, alkanes, and tropospheric ozone. So there are ozone in that mixture. So in the stratosphere, ozone is a valuable gas which absorbs ultraviolet B radiation. But in the troposphere, that means in the lower level, lower level, ozone is a toxic gas. It is carcinogenic. It is a it has high oxidative power. It is a bleaching agent. And photochemical smoke consists of peroxyacetyl nitrate. To generate the photochemical smoke, three ingredients are required. Ultraviolet light, there should be sun rays. So during the daytime, smoke is formed. Hydrocarbons are required, volatile organic compounds, and nitrogen oxide. So the hydrocarbon, nitrogen oxides, with the presence of sunlight, produce ozone gas, peroxyacetyl nitrate, and other oxidants such as aldehyde and ketones. This is what happened in the photochemical smoke formation. So all of you know the photochemical smoke is a local problem. Global warming is a global problem. Greenhouse gas effect is a global problem. The acid deposition is a regional problem. The formation of photochemical smoke can be happened to a specific area, can be happen to junction, to Mahanura town likewise. So, what happened? The vehicles and factories emit hydrocarbons and oxides of nitrogen from the morning, and with the presence of sunlight, these nitric oxide, nitrogen oxides, and hydrocarbon react with each other and formed peroxyacetyl nitrate and the ozone. So here you can see nitrogen dioxides with the presence of sunlight are converted into nitric oxide and oxygen atom. This oxygen atom will react with the this oxygen atom will react with the O2 molecules, oxygen molecules, and form ground level ozone. So that is called as the tropospheric ozone formation or the ground level ozone formation. So, unburned hydrocarbons and exhaust gases from motor vehicles and unburned hydrocarbons going released from the factories and the exhaust gases from the vehicles are responsible for the formation of photochemical smoke. So, volatile organic compounds like RCH3, usually R is represent for alkanes. Okay. Carbon-based molecules such as aldehydes, ketones, and hydrocarbons. So these volatile organic compounds react with nitric oxide and oxygen and create aldehyde, NO2 and H2O. So paint thinners, solvent, petroleum constituent, some trees, and methane from termite, cows, cultivation. Those are the sources of volatile organic compound emission. So the termite, where cows and cultivation, that livestock sector, and even the agriculture is responsible for the emission of volatile organic compounds such as aldehyde, ketones, and hydrocarbons. And some trees emit isoprene and terpenes also. So likewise, these aldehyde react with the OH radical and create these compounds, and at the end this peroxyacetyl nitrate is formed. So this is a secondary pollutant. Even ozone, ground level ozone, is a secondary pollutant. And let's see what are the effects of those gases in the photochemical smoke. Ozone, it causes acute respiratory problem. It can cause eye irritation, skin irritation, throat irritation, aggravate asthma, cause temporary decreases in lung function in healthy adults, lead to hospital admission and emergency room visits, impair the body immune system. Pan gas, it mutagenic, causing skin cancer, chana විකෘති කරනවා, respiratory and eye irritants. Volatile organic compound, global warming, carcinogenic, and form ozone. So some volatile organic compounds such as methane, they are very good greenhouse gases. So they can cause global warming. And especially benzene like gases, they are carcinogenic. And some are helps to form ozone. So tropospheric ozone affects to the photosynthetic process of plants because ozone has oxidative power. So the chlorophyll is oxidized, then the photosynthesis will be retarded, reduced. Affects the coating of paints in building and degrade material. They have bleaching power, corrosive. Health effect, irritate skin, eyes, respiratory problem, and carcinogenic, පිළිකාකාරක, and ozone is a greenhouse gas effect. It's a greenhouse gas. So let's see how to reduce these things. So we can reduce emission of primary pollutants. We can reduce emission of primary pollution, nitrogen dioxide, volatile organic compounds mainly emitted from vehicles and industries. So if we reduce the emission of nitrogen dioxide and the volatile organic compounds from the uh, industries and the vehicles, we can reduce the formation of photochemical smoke, because the sources for the required raw material are the nitrogen oxides and the volatile organic compounds. So for that we can use catalytic converters. So nowadays usually vehicles are consist of catalytic converters. Usually they are three-way catalytic converter. So they using a catalytic converter, we can reduce the nitrogen oxide into elemental nitrogen and oxygen. That means the nitrogen oxide is converted to N2 and O2. And again, this catalytic converter can oxidize carbon monoxide to carbon dioxide. And the catalytic converter can convert or oxidize hydrocarbon into CO2 and H2O. So if there are emission of methane or other non-volatile gases, so they are again oxidized and CO2 and H2O is emitted. Because CO2 is a greenhouse gas, but it is less toxic compared to the emission of non-volatile gases like methane. So usually catalytic converters are available in the uh, vehicles. So let's see more information about catalytic converter. Uh, so modern catalytic converter has two purposes. One is to convert carbon monoxide, nitrogen monoxide to nitrogen and carbon dioxide. You know carbon dioxide is a very toxic gas. So the carbon monoxide when react with blood, when react with the hemoglobin with the blood, what happen, it create a stable compound. Huh? Then what happen, the people can die. To avoid that, the emission of carbon monoxide has to be reduced. So for that the catalytic converter can oxidize the carbon monoxide into CO2 and H2O. The other is convert unburned hydrocarbons, which are responsible for the pan peroxyacetyl nitrate, to carbon dioxide and water. So this is a picture of a catalytic converter. Usually it has a honeycomb design. So honeycomb design, so that means me වදයක් වගේ. So those the catalysts are available in honeycomb design. Because of that, the area of the reactant surface is increased. Therefore, the flue gas coming from the vehicles is contacted with the catalyst and oxidize and reduce into CO2, CO2 and elemental nitrogen. The catalyst may vary from one to another. The common catalysts include palladium, platinum, rhodium, nickel oxide, cuprous oxide, chromium dioxide. The internal honeycomb design maximizes the surface area available for contact between the exhaust gases from the engine and the metal or metal oxide catalyst. So, as I show you, you can see. And so, usually, this is the place uh, for the catalytic converter in a vehicle. So, these are the main reactions occurred in a um, catalytic converter. And there are lead and catalytic converters. So if there are leaded gasoline, so in our country, leaded gasoline is no longer used. So leaded gasoline molecules have four ethylene groups bonded to a central lead atom. They burn evenly in car engines, reducing a condition called engine knock, which is associated with burning straight chain alkynes. Okay, so leaded, all of you know, leaded gasoline is banned in our country, and it is also banned in some countries because lead is a poison to human being. So lead not only poison people, it also poison converters by binding to catalyst. Once it becomes covered in an impurity like lead, converter can no longer absorb CO and NO molecules. So if there are leaded gasoline vehicles, then we have to think about using a catalytic converter because it poisons the catalytic converters also. So now we are talking about preventive measures of ground level ozone formation or the photochemical smog formation. So for that we can use lightweight fuel. So once we use gasoline and kerosene, diesel, then those alkane, aldehydes, so the heavyweight fuels, when you use those non-volatile organic compounds are released into the atmosphere. So if we are using a lightweight fuel, we can reduce the emission of non-volatile organic compounds. So for that, we can propose natural gas. So there are LP gas-driven vehicles in our country also, but it is not easy. We have to convert the engine configuration into for to driven by LP gas instead of having a diesel-driven or petrol-driven engine. So if you are using those LP gas, the emission of SOx's, NOx's also be reduced, and also the emission of volatile organic compounds will be reduced. And also there are hydrogen fuel driven vehicles in the world also. Then prevent solvent evaporation from factories. So the spillage, leakage of solvents has to be stopped, has to be minimized in the industries. So during the spillage or during this leakage, those solvents will, the molecules will be released into the atmosphere and uh, cause the formation of photochemical smog. And in our country it is not difficult, it is difficult to form photochemical smoke because due to the high wind turbulence, because of the high wind turbulence, and our country is small, is a island surrounded by the sea, and due to the high wind turbulence, they cannot be accumulated into one place. So in a hill country, if there is a higher amount of air pollutants, then there's a possibility to form photochemical smoke. So the topology, that means the Bhushamattavya, is affect to the formation of photochemical smoke also, not the availability of the sunlight and availability of the air pollutants and also the wind turbulence. Those are affect to the and the temperature. Those are affect to the formation of photochemical smoke. So I just thought to share this information. Refrigeration cycle. So this is a refrigeration cycle. Sometimes you may have learned them in the semester one. And my dear students, I'm not going to ask any question from this refrigeration cycle, but I just want you to share. So in refrigeration cycle, those CFC, HCFCs are used. Those the compounds which are responsible for the ozone layer depletions. Then this is, what is this? This is the steam power plant cycle. So here boiler, the steam is generated, then turbine is run, then turbine exhaust is coming out and it is going through a condenser and again it is pumped to the boiler. So that is the end of the ozone layer problem. And now I think I have completed all the lectures of the air pollution and control section. So the first lecture is about introduction to the air pollution. So in that lecture, you learn about the what is air pollutant, the types of air pollutant, the sources of air pollutant, primary air pollutant, secondary air pollutant, and the type of emissions. Likewise, you learn. Then in the second lecture, you learn about the acid rain, acid deposition, and the third one, you learn about the ozone layer depletion and the photochemical smog formation. And in the fourth lecture, you learn about greenhouse gas emission. So my dear students, the most important thing is you have to know is the preventive measures and the controlling measures of air pollutions. So you learn many problem, many environmental problem caused due to the anthropogenic activities or the cause due to the man-made activities. So then you should know the preventive measures and the controlling measures. As a technological student, you should know the preventive measures and the controlling measures. So as air now you know air pollution control equipment. So for the polymer students, you learn about some unit operations used for the air pollution controlling. The cyclone separator is used to uh, trap or catch particles from an airstream. Then wet scrubbers are used to catch water soluble solution gases. So not only water soluble gases, but also if we use another liquid, then we can trap some gases like carbon dioxide. Then there are many other equipment like fabric filter, bag filter, electrostatic precipitator. So those are the air pollution control equipment.